We're in 6.5, problem number 5. It says, suppose that X has a distribution with mean 90 and sigma standard deviation of 8. All right, now, if random samples of size 16 are selected, can we say anything about X bar, the distribution of X bar? I think what they're getting at is, can we say this? Can we say X bar is normal? Can we say that? Well, we don't know anything about the population. It just says X has a distribution. It doesn't say anything about the distribution of X bars. Now, here's what I know. Here's what I know. This is true. All right, that's going to be true when n is greater than or equal to 30. Our sample size is only, where's our sample? It's only 16. So I think it's too small. I don't think we can say anything about this. Let's see what our choices are. Can we say any? No, right there it is. It's the only no. No, the sample size is too small. So we can't say anything about the distribution of X bar. Now in part B it says if the original distribution is normal. All right, so now we know that the original distribution is normal. Can we say anything now about the distribution X bar? Yeah, as long as we know it's normal, the sample size doesn't matter anymore. So what can we say? Yes, X bar is normal with a mean 90. Where'd the 2 come from? I think it's going to be this one here, right? Yes, it's normal with a mean of 90 and a standard deviation of 8. So let's choose that one. And then we're supposed to get this probability. What's the probability that X bar is between 86 and 91? We can do this directly on our calculator, but I'm going to draw a picture anyway. Helps me know what I'm put in my calculator. All right, so let's see. The mean is what? The mean here is 90. All right, so the high point is 90, and we want to go between 86 and 91. All right, so right up to there. So what's the probability of getting an X bar, right? These are X bars in that interval. So we're going to find that probability by just measuring this area right here. And we're going to have our calculator measure that for us. So let's go to second, VARS, over to number 2 to get normal CDF. Now the low is 86, so we'll type in an 86 here. The upper is 91. The mean is 90. Now, sigma, we've got to be careful here because we have a sample of size 16. So it's going to be, remember what it is here? Sigma of the X bars is really sigma divided by the square root of n. All right, so the sigma that we're given up here in the top of the problem is an 8 divided by square root. Now put in 16. Well, you can do that one in your head. Okay, and then let's compute. So when I made that computation, I got 0.6687 and then a 1. All right, so if I go to 4 decimal places, I'm at 6687. So we're supposed to put that all the way back up here on the top left. 0.6687. All right, so there's about a 66.87, about a 67% chance that you would randomly pick a sample of size 16, find the mean, and that mean would land over here in this picture. That mean would land in that interval right there, somewhere between 86 and 91. And problem number 6, the last problem in this section, says, consider an X distribution with standard deviation 30. All right, now A, if specifications for a research project require the standard error, now the standard error, let's just remember, the standard error is this. The standard error, when we're dealing with the mean, is that's the sigma over square root of n. What do we have? Okay, we want that to be 2. All right, so we want this to equal 2. We want the standard error to be 2. Now the question is, how large a sample size do we need? Okay, so there is a formula for this. Maybe you remember it, but if you don't remember it, you can get it from this one right here. Here's what we know for a sample size, right? We know this, that the error is sigma over square root of n. Now, what if you multiply by square root of n? Okay, then you get e times the square root of n is equal to sigma. Now, let's divide, right? Let's divide by that e. We'll get the square root of n is equal to sigma over e And then if you square both sides, right, get rid of that square root, we'll get n is equal to, I'll put in square brackets, sigma over e squared, and you always, it's a sample size, so you round up. All right, so what do we want here? Here's what we have. I'll do it over at the left side over here. Here's what we know. We know the standard deviation is 30. So sigma we know to be 30, and the error has to be 2. All right, so what are we going to get here? This is going to give us that n, our sample size, is 30 sigma over e, 2, okay, squared. Oh, this turns out to be 15 squared, which is 225. How nice is that? Didn't have to round at all. So the sample size has to be 225. And now this last part down here, let's see, what do we have for the error now? Oh, just to be a 1. Okay, so just to be a 1, what we're going to have is, all right, n will equal 30 over 1, right? 30 over the error squared, that's just 30 squared, which is 900. All right, so now we're at 900. So you see what happened here. We wanted our error in part A, we just wanted the error to be, we wanted to be within 2 units. Or whatever we have a project, we want to get the mean, and we want to be within 2 units. So we need 250, we have to sample 225 items. But if we want that error to be just 1 unit, now we have to go up to 900 items.